Now that we've outlined how Pascal's triangle can be used with probability, let's apply it to the following problems. The first problem we have is find the probability of hiring 6 men and 2 women by expanding the binomial expression, the quantity m plus f to the 8th power. Now, just so we can know in future reference on how to create our own binomial, we see we're hiring men and women, so M plus F represents the hiring of men and women, F for female. Now, if we're hiring 6 men and 2 women, that means our exponent out here is going to be a total of 8. So that's how we generate our own binomial expression from this. And we'll look at that further in the second problem in this exercise set. So first, what we're going to do is kind of look at the row. The 8 tells us we want to look at the 8th row. So this is where we're going to focus, right down here. And I know that looks like a lot of coefficients, and it is, but it's a lot easier than what this looks like. So that tells us the power tells us the row. So we're going to examine the 8th row. Now, what also we need to keep in mind is that the situation, the outcome, 6 men and 2 women, that tells us our exponents for M and our exponents for F. 6 men and 2 women means we want to look for the term that has the following exponents. We want to look for the term where M has an exponent of 6 and F has an exponent of 2. 6 men and 2 women. And so what we're going to do is we're going to expand this row until we see this term. And so hopefully before you work on this, you've watched the videos dealing with how to expand a binomial expression using Pascal's triangle. So to expand it, we're going to first start with our coefficients. So I'm going to start with 1. So I have 1, and since it's the 8th power, I'm going to have m to the 8th. And as we continue down, the next coefficient's 8. Remember, the exponent for m decreases as the exponent for f increases. So there was no f here, so there's an f here. If you want to put the 1 there, you can. And then I'm going to have 28. Here it's going to be m to the 6th because I'm decreasing. And since I'm increasing, it's going to be f squared. Now, before I continue on to the next term, I said I want m to the 6th f squared, and I have it right here. And so this is the term I'm trying to find. And so our probability is equal to the coefficient, which is 28, over the sum of the entire row. So we could do 1 plus 8 plus 28 plus 56 plus 70, and I can rewrite that entire row, which is very, very, very tedious. And that's why in the previous video, I showed you there's a pattern. If I were to add up all of those numbers, then I would see I would get 256 on the bottom, which is the same as saying 2 to the 8th power. And so instead of rewriting the entire row, I can just say, well, I know my exponent is 8, so the sum is going to be 2 to the 8th power. And then I can easily get the number of the denominator rather than having to either type this whole thing in my calculator or write it all out and do basic addition, which is more fun, but we're not going to do that. So just put 28 over 2 to the 8th and 28 over 256. So that's your probability. If you type that in your calculator, you're going to get 10.9%. And so that is the probability of hiring 6 men and 2 women found in this situation by using the binomial expansion. So before we move on to example 2, the power tells you the row in the triangle. The term is found by using these as your exponents. I personally prefer to use the shortcut. The sum is 2 to the power. That gives you the sum of the row you're trying to find. You take the coefficient and you divide by the sum. So let's try example 2. Now, if you toss a coin 5 times, how many different sequences of tosses will be exactly 2 heads and 3 tails? Let H be heads and T be tails. So here we're actually going to create our own binomial power for us. So to do this, we're being told H is heads and T is tails. So let's use the same idea as in the previous example. We have parentheses H plus T. We're flipping the coin 5 times, and so that means this is going to be our power. So there it is. That's as simple as it is to create your own binomial. Is look at what the two events are, flipping heads, flipping the tails, how many total times, and that's your exponent. Now, this part, remember, tells us what term we're trying to find. 2 heads and 3 tails means we're looking for the term with h squared and t cubed. So same idea as before. The power tells us the row that we're looking for. So I'm going to be looking at this row right here. That allows me to expand my binomial. So I'm first going to have a 1 h to the 5th plus next a 5 h to the 4th. So the h's exponents decrease, the t's are going to increase, so this is going to be a t to the 1st. Not quite there yet, so I have a plus 10 h cubed t squared. And I want h squared, so I'm going to move on to the next one. So that's plus 10 again. I decrease the h, which gives me h squared. I increase the t, which gives me t cubed. And that is the one I'm looking for. And so this is the term I want, 10h squared t cubed. Now this problem just asks how many different sequences of tosses will be exactly 2 heads and 3 tails. That's what 10 represents. So really the answer to this is 10, but that's no fun. I want to continue on and I want to find the probability just for more practice like what we did before. Now remember the probability is going to be 10 over the sum of the row in this example. Well, the sum of the row, if you want to go ahead and type in 1 plus 5 plus 10 plus 10 plus 5 plus 1 and be that student, then go ahead and be that student. However, remember the shortcut. It's very simple. This would be 2 to the 5th power. So that's going to be 10 divided by 32. And if I type that in my calculator, I'm going to get 31.3%. And so it's that simple to use Pascal's triangle for probability, for determining the number of occurrences in the situations. So I hope you found that helpful, dealing with Pascal's triangle with expanding and probability. And next thing we go on is the binomial theorem.